Hello friends, in this class we are going to talk about data structure for 3-address code. Hello everyone, and in this new section we are seeing the data structure required to represent 3-address code. Okay, so there are how to present these instruction in data structure. So that is the idea, that how we are going to present these instruction in data structure. So instruction means we are talking about which instruction? The 3-address instruction. Okay, so how we are going to present these 3-address instruction in data structure. So there are 3 different ways of representing this 3-address instruction, and among this is quadruples, triples, and indirect triples. Okay, so there is a quadruple. There are 4 different fields are there, 4 field, and here triples means there are the 3 field will be there, and indirect triples means we have some sort of let's say a situation where we have some address stored. Okay, so address stored, so there will be indirect. Okay, so let's see one by one this quadruples, triples, and indirect triples. Welcome again, and the first data structure here is the quadruples. Okay, so quadruples as it stands for is having 4 different fields. There is an operator OP, and there is argument 1, argument 2, and then finally there is a result. If you are having a unary operator, then there will be no argument 2. Okay, only there will be argument 1. Operation like param means your the parameters. Param means your parameter. No argument 2 and no result. Okay, so when you are passing as a parameter, so there will be no argument 2 and no result. Unconditional, conditional, and unconditional jump, target label will be at the result. So when we say let's say go to L, okay, so this is your target label. Okay, so this is the target label, and that will be in the result part. Fine. So let's use this 4 different field. T1 is equal to minus. So operation here in this case is minus. Okay, let me put in a different color. Okay, so here this is minus. Okay, there is a minus. And what does it say? That there is no argument 2. Argument 1 will be C, and result will be your T1. Here we have operator multiplication. Argument 1 is B, argument 2 is T1, and result is in T2. Then again minus C, so there is a minus. There is only argument 1, that is here again C, and the result is in T3. T4 is the result part, and there is again a multiplication. I am talking about this one, and argument 1 is B, argument 2 is T3, and result is in T4. Next is T2 plus T4, and in this we have a operator is addition, and here it is T2, and this one is T4, argument 2, and result is in T5. Finally, we have operator equal to, and here we have a argument 1 as T5, and result is in A. So this is your example of your what? Example of quadruples. Okay, quadruples. This is how it has resulted. Unary operator parameter is having no argument 2, no result, and no result. Unary operator has no argument 2. Minus we have seen, and unconditional jump, target level be at the result. So there are few small and important points are been written over here. Okay, so I hope you understand this example and how this TAC 3-address codes are being represented as your quadruples. Okay, so that's all for this. Thank you. Welcome again, and the next data structure here is that is used for storing this TAC 3-address code is the triples. Okay, so the idea is that to avoid temporary names into the symbol table. Okay, so to avoid the temporary names in the symbol table, we might refer the temporary value by its position. Okay, so we will refer to this temporary value by its position of the statement that computes it. Okay, so that is the idea here, that we will not store t1, t2, t3 temporary variables in our symbol table. Rather than we'll just refer to it by its position. So operator here is minus, like here minus c. So minus I will put over here, and then argument 1 in this case is c. Okay, c, and I will call this as a zeroth position, or let's say call it as just not to have any confusion, let's call this as position number 1. Okay, so let's call it as position number 1. So 1 position. Now here t2 is okay, so now here operator is multiplication, and b is one argument and another argument is t1, so that is referred by position number 1, and let's call it as t second position. Then again there is a minus c, so minus c, and let's call it as position number 3. Then there is a t4, fourth position, and there is a multiplication, and then there is a b, and then there is a position number 3, t3, and let's call it as position number 4. Then let's have a plus as an argument, and here t2, so that is position number 2, and then there is a t4, so that is position number 4, and let's call it as 5. Then assignment treatment is a bit different over here. This is 6 and assignment, and here the idea here is that argument 1 and argument 2 both places are used here, and here we'll write a, and in this way we'll write the position 5. Okay, so that is the idea of this triples, and the only thing is result fields are referred by its position. Okay, so these are the, when I am writing 1 3, so these are the nothing but results. We are not showing the result over here, so its position. Okay, position represents result field. Okay, so that's all for this. Thank you. Welcome again, and the next data structure is the indirect triples. Okay, so indirect triples we are learning for storing the 3 address code. Okay, TAC. When the instructions are moving around during optimization. Okay, so this is something that is related with the reordering. Okay, so reordering of instructions. So sometime for optimization purpose we have to reorder it. So reordering of instructions. Quadruples are better than triples. Okay, so there we have the particular what is the difference between quadruples and triples, that the result field is not there. The result is not present in triples. So quadruples are better. Indirect triples solve this problem. Okay, so now here we have a minus operator, and then c, just now we have done, and then before that we have a position number 0, and then minus, then c again, then b, and these 2 position. Okay. Now what will happen in this case is the instruction ordering is there, that is 35, 36. So 35 instruction refer to the 0th number instruction, then 30. So these are the list of pointer to the triples. Okay, list of pointer to the triples, and optimizing compiler can reorder the instruction list instead of affecting the triples themselves. Okay, so we can have a instruction may change its order. So now I am changing this order 1, 2, this 35, 36, 37, 38, 39, 40, and what we can do here is we can have an indirect reference to this instruction. So indirect reference to this instruction. Right, so I think this example is not clearly reflecting that particular condition, but here 35, now you can move it around, or can reorder. 35 is the 0th number of the instruction, 36 is the first number of the instruction. Okay, so these are the nothing but the pointers there. And if you change the pointer here sometime, you know, like this 3 is becomes move around, 3 comes over here, and if 2 comes over here, then we can directly handle it by using the pointer. So this is indirect triples. Okay, so that's all for this. Thank you.